All right. So let me go into my plots. Change it to, you said a box plot? What did I do? I hit one too many keys. Here we go. And that's going to be the residual list. Okay. You do a zoom 9 here. Not bad. You know, it's not real skewed. So a short line, and then nice long middle, and then a little bit longer line here. Yeah, that's not bad. Okay. No skew. We'll just say that's not skewed. Okay. Check my conditions. Maybe good to go. Maybe didn't quite meet my conditions. I think on the independence didn't meet my conditions, but we'll go ahead anyway because we need to do a procedure. Need a what? Need a haircut? Who? Oh, gosh. Yeah, that would give us an indication that of non-normality here. And so yeah, if you see some outliers, you might want to say we didn't meet conditions. Okay, now we're going to do our confidence interval. Our confidence interval is the slope of the sample plus or minus critical, and we're going to use a critical t, times our standard error, and the one we're going to use is the standard error of the slope, but remember that included the s in its calculation, but we've already got that number somewhere. Okay, so what was the slope of your regression line? And you can find it? Just run the linear regression again, it'll pop right out. 9.32 plus or minus. Now, my degrees of freedom is going to be n minus the number of variables. And there are two variables here, so this is n minus 2. So my degrees of freedom is 11. We're doing 95% confidence. So I need to go to my t table, find for 11 degrees of freedom the critical value. And that was, I wrote it down earlier, so hopefully I can find it again. Huh? Oh. Yes and no. If you don't, let's see. If you're not including estimating like the y-intercept, you only do n minus 1. But if you think that your y-intercept is varying, then you need to do n minus 2. But if you think your y-intercept is constant, then you just do n minus 1. Okay. Okay. What was the standard error of the slope? 0.31? All right. Calculate your confidence interval for me. This shouldn't be too hard. This is just an addition and subtraction problem with a little multiplication. I'm not asking you to do it by hand. 8.64 to okay. So we are 95% confident that the slope of the least squares regression line is between 8.64 and 10.00. Slope has units. So it was kind of a lean amount of lean, which I think was in millimeters. No, they did it in millimeters. I don't, like I say, it was some kind of weird difference from 2.9 meters. I don't know. It was way too complicated for me to get. So this was in millimeters by the year, because the year was our input. Is between millimeters per year for lean amount by the year. Oops. I repeated that because this millimeters, like millimeters of what? It was some kind of lean amount. Sorry, I didn't write amount out, did I? Amount. A year. Okay. Now, good news, bad news. Some of your calculators will do all this for you. Mine does not. Yours may. So look at your linear regressions. If you have a linear regression t-int, your calculator will do the confidence interval for you. And if you don't, then you have to do some calculations yourself. Okay? But, good. Little more good news, bad news. Yeah, you only have the test. I only have tests. I don't have the other. No. All right, so Danielle asked a little bit earlier about output. And if you're reading output, for your confidence interval, you need the standard error of the slope, and that is the number right next to the slope number in the output. Ba-boom. Okay? There is also on your output the S, and it's always written off to the side. It's not in that same line. So if you've got output and you need to do a confidence interval, you need to grab the slope off the second line, the coefficient, and the standard deviation of the slope right next to it. Okay? So on one of your problems for tonight, you get output, and the other one you don't. Sorry.